Okay, good morning.
Okay, so we apologize for the delay. There were a few technical issues, but at least now we can start. Okay, so this session is going to be a brief one, and we are basically going to go through a few questions that cover the various topics that we're supposed to do in algebra, that is Math 151 for this semester. Basically, it was under number systems, which included real numbers and then um, complex numbers, and then it moved on to vectors, everything under vectors, and finally matrices and eigenvectors. So we'll touch on questions on each of all these areas so that at least we can equip ourselves properly for the upcoming exam. If you check the description box, right, there is a link to the first set of questions that we will be solving. And so do well to click on that link to get your access to the questions, right? So that you can follow along. Okay, so at this point, we would start going through the questions so that everyone can get it in the normal standard form that we do. And a complex number is in the standard form if it's in the form, sorry, if it's of the form z is equal to a plus bi, right? So if it's of this form, then we say that the complex number is in the standard form, and that's where we can get this being the real part and the term with I being the imaginary part. Now, how do we go about this? Let's go ahead and then solve it. So we are having 1 over e to the power I theta plus 1. And we are supposed to find the real part of this. So in order to transform it, there are quite a number of ways that this can be done, right? So I would just go by one approach. So what we can do is to reduce the denominator in such a way that it can give us a certain numerator, right? So if we convert this to something of this form, so I theta over 2 multiplying e to the I theta over 2 then plus e to the I theta over 2 negative. Now, the reason why this was done is I just did a little factorization at the denominator, right? So let me use this section. Sorry. Okay. So assuming you have, let's say, e to the I theta plus 1, right? This is the same as e to the power I theta over 2 multiplying e to the power I theta over 2 plus 1 over e to the I theta over 2, right? Now, you can see very well that if you multiply these two terms, you are going to get e to the power I theta. And if you multiply this with this, you are going to get 1, right? So that was simply what we did at the denominator. So let's go back so that we can continue with the solution. All right. So it becomes 1 over, then we have e to the I theta over 2 multiplying e to the I theta over 2 plus. Remember I mentioned that this becomes e to the minus theta over 2, right? Okay. Now this can be transformed into e to the power minus theta over 2I all over e to the power I theta over 2 plus e to the power minus theta over 2, right? We can do some modifications to the denominator, right? I'm sure you have seen this before. So if you have a complex number, let me quickly prove it using the Moab's theorem. If you are having, let's say, e to the power I theta plus e to the power minus I theta, right? This becomes cos theta plus I sine theta plus this side you get what? Cos minus theta, then plus I sine minus theta. And this term cancels this term. So you get what? 2 cos theta. That means at the denominator here, we are going to get, if you have any questions, you can simply put them in the chat box so that we can rectify them. I would do my best to answer them for you. All right. So comparing what we have here, this here. So comparing this to the denominator we have, it becomes what? 2 cos, and then the theta we have is what? Theta over 2, right? And our numerator still remains as e to the power minus theta over 2I, right? We are getting it in a familiar form. You get it? And if we go ahead and then continue with this solution, we are going to get, remember that this is a past question from one of the lectures, right? So if it should come, you should know how to find your way around it. First, decompose the denominator in a way that you can at least make way, right? Okay, and so with from here, what we have to do is work on the numerator, right? Remember that if you have e to the power, we have this side to be e to the power what? Minus theta over 2I. And don't forget that if you are having e to the power I theta is equal to what? Cos theta plus I sine theta. So this numerator becomes cos open bracket minus theta over 2 plus I sine. Let me write it here so that you can see clearly. Okay, so this becomes what? Cos, then minus theta over 2 plus I sine minus theta over 2, all divided by our 2 cos theta over 2, right? Then we can go ahead to, remember, if you have a plus b all over c, it is the same as a over c plus b over c. So this becomes what? And cos minus theta over 2 is the same as what? Cos theta over 2, because cosine is an even function. So but if you have cos negative theta, is the same as cos theta, right? All right. So this becomes what? Cos theta over 2 all over 2 cos theta over 2 plus we have I sine minus theta over 2 all over 2 cos theta over 2, right? Now we can see that this term here is going to give us half, right? Then in the sign, there is a minus over there, but for sign, if we have, let's say, sine minus theta, right? It's the same as minus sine theta. So this becomes minus, and then there is another sine over cos. So let me just skip that and then write sine theta over 2 all over cos theta over 2. And this transforms to give us what? Half minus I tangent of what? Theta over 2. You get it? So this is our real part, and then this is our imaginary part. So the real part is what? Half. And the imaginary part is minus tan theta over 2. Now, if you should get this in the exam hall and you are not sure how to go about it, you don't really, if it is objective questions, you don't really need to solve everything. You can simply convert your calculator to a complex mode and then put in values, different values of theta. You would realize that for any value of theta you put in, you are getting half minus then an imaginary part which will be changing, right? So that is how we go about this particular one. Now I'm sure you get it. Let's move on to the next question. If you have any questions, you can let me know so that we work on them, right? Okay, so for the second question we have here, we are told that a certain matrix a certain matrix A has been given, and then the I is the identity matrix. You are supposed to find the determinant of that matrix, right? So what you simply do is you are supposed to find the determinant of this matrix, this. But if you observe very carefully, you can see that A squared, you can see that A squared plus 2AI plus I squared is the same as what? A plus I all squared. Let me move this. All right. So we're given the matrix A. So matrix A is giving us. So for the entries of the matrix, we have. So we have minus 5, 2, 3, 0, 2, 5, 0, 0, minus 3. So minus 5, 2, 3, 0, 2, 5. Let me verify. Yeah, 0, 2, 5, 0, 0, minus 3. So 0, 2, 5, 0, 0, minus 3. And we are supposed to find the determinant of what? A squared plus 2AI plus I squared. Now, I said this is the same as what? A plus I all squared, if you check closely. So it simply means we are supposed to add A to I and then square that. Now, the I is our identity matrix, which we all know as what? Sorry, 1, 0, 0, 0, 1, 0, 0, 0, 1, right? And if we are to add A to I, it's simply going to be minus 4, 2, 3. The zeros cause all the other entries to repeat, right? So 0, 3, 5, and then 0, 0. Minus 3 becomes minus 2 because we've added 1 to it. And we are supposed to find A plus I all squared, right? So A plus I all squared here, and then it's going to give us minus 4, 2, 3, 0, 3, 5, and then 0, 0, minus 2. Now we are multiplying this by itself, You can do this with a calculator if it happens that your question is an MCQ question, right? So if it is not written, you can simply punch everything into the calculator and then do the multiplication or the squaring with your calculator. Okay, so when we do that, we are going to get what? Minus 16 here. And then for the second one, we are going to get negative 4. So negative 8 plus 6, which is what? Minus 2. And then for the last part, we get what? 16, sorry, minus 12, then plus 10 minus 6, right? Which is going to give us minus 8, right? So minus 8. And then for the second row, we are going to get what? 0 here. And then for the second term in the second row, we are going to get minus 8, then plus 6, plus 0, which is what? Minus 2. Okay. So for the last one, you can simply do this with your calculator. So these ones, you don't really need them. So minus 12 plus 10 minus 6, right? Which ends up giving us, similar to what we had at the top, negative. Oh, sorry. So that one is just going to be, let me erase this. Okay, there was a little issue over there. So for the first one, just minus 16, that's what you are going to get when you do your multiplication. Then for the second one, minus 8, you know how to do the multiplication. So minus 8, then plus 6, then that is giving us a negative 2. And then we have minus 12 plus 10 minus 6, which is giving us negative 8. Then we move on to the second row where we have here to be 0, because there is 0 in every multiplying term. Then we have 0 here plus 9. That gives us 9 here. And then for the last one, we have 0 plus 15 plus 4, right? That gives us 19 here. Okay, so let's continue. Um, so for the last part, we have 0 here. And then if you watch closely, we have another 0 here. And then this side, when we multiply the last, then we are going to get what? 4, right? Okay. Now, that is for the squared, right? That is for the squared. And it's going to give us what? Okay, so we are getting this quantity here as a plus I squared. But the initial question, if you check the initial question, it says that we should find what? The determinant of that square. So the determinant here, if you look closely, the matrix we have here is an upper triangular matrix, right? It's a triangular matrix. And for triangular matrices, if you are finding the determinants, it's simply the multiplication of all the terms on the diagonal, right? So this is simply going to be, determinant is equal to minus 16 times 9 times 4, right? And this is going to give us minus 576. Okay, so this is the answer to our question. Now, if you check carefully, you can make some deductions over here, right? If you check A plus I is also a triangular matrix, right? And so this is the determinant of A plus I. The determinant of A plus I is going to be what? Minus 4. So minus 4, negative 4 times 3 times negative 2, right? And then this is going to give us what? So this is going to give us 24, right? Yes, 24. Now, if you check 24, oh, sorry, this should be coming, this should be positive 16. This side, it should be positive 16. All right. So positive 16, this gives us positive 257. Now, if you do the comparison, you see that squaring the determinant of a matrix, right? If you have a matrix A, right, and you find the determinant, so determinant of A all squared is equal to, then determinant of what? A squared, right? You can make this deduction from that. All right. Now, I hope you are getting it. If you have any other questions, you can let me know so that we work on them, right? Okay. So let's move on to the next question. Let's move on to the next question. So we are supposed to find, now this particular question is one question that usually disturbs students. The understanding of unit vectors does not really come out well. So you are supposed to find someone is making, okay, so let me move on to the next question. We are supposed to find a unit vector which is, okay, it appears the Google link, the link that has been placed in the description box has not been made public. So let me make that public so that we can continue quickly. All right, so sorry for that. The link in the description box is now accessible so that you can all view the questions as we go. All right, so we are supposed to find what a vector that is perpendicular to both A and B, and we've been given A as follows. So let's move on to solve that one as well. All right, so we've been given A as what? 2I plus 5j plus k, and then our B is what? 3I minus j minus k, right? So we are to find the unit vector that is perpendicular to both A and B. Now, which vector is perpendicular to both A and B? How do you get a vector perpendicular to both A and B? For a vector to be perpendicular to both A and B, it means that what? That vector should be the cross product of A and B. If you understand the concept of cross product, you are having, let's say, a vector here, another vector here. Let me do this. The cross product is the vector that is what? Perpendicular to these two. So it would kind of come out of these two, right? You can liken it to a football pitch. At the corner post, you would see that there are two height lines over there, and there is a pole standing, right? So the two lines on the ground are your vectors, and then the pole that is standing is perpendicular to the two lines, and so it is your cross product, right? Now, to be able to work cross product, you can simply do that with your calculators, right? Um, I'm sure you all know how to do that, so I'll quickly skip that step so that it doesn't waste time. So let's go on. So vector, vector perpendicular to A and B is A cross B, right? Now, A cross B, right? Let me quickly do that with a calculator so that it doesn't waste our time. Okay, so we have 3 minus 1 minus 1, and then we have to save that. So, all right, when you find the cross product of A and B, you are going to get minus 4I plus, sorry, so plus 5j minus 17k, right? This is the vector that is perpendicular to the two of them, right? Now, the question was specific. It says we should find a unit vector that is perpendicular to this. So if we found the vector perpendicular to this, how do we find the unit vector of this vector, And remember, unit vector is just simple. So the unit vector usually represented by u, right? So let's say u is equal to then a here dot b. So it's simply the vector. Let me just use the commonest method that we all know. Unit vector is just the vector divided by its magnitude, right? So you have a vector like this. Let's say it has a magnitude of 10. The unit vector of this is just this vector here divided into 10 parts, right? Divided into 10 parts. All right. All right. So how do we find the magnitude of this? So it's just A cross B over magnitude of A cross B, right? We know A cross B already, and so we just go ahead to find the magnitude of A cross B. That is going to give us what? The square root of minus 4 squared plus 5 squared, then plus minus 17 squared, right? Let me just punch that in the calculator quickly. We are getting root of 330, right? Root of 330. So then our final answer becomes 1 over 330, sorry, 1 over root of 330 times the vector, which is minus 4i plus 5j minus 17a, right? I hope we understand up to this point. So this becomes our final answer. This is our final answer. All right. So let's move on to the next question so that uh, we can make way. So for the next question, we are told that what? A complex number equation is given as z squared is equal to z squared. The equation is given by z squared is equal to 1 plus root 3 all squared. Solve the equation leaving your answer in the form a plus bi, where a and b are real numbers. So I think there should be an I here. There should be an I here, right? So it is z squared is equal to 1 plus I root 3 all squared, right? That is what it should be. Okay, so we have to solve um z squared is equal to then 1 plus I root 3 all to the power 2, right? You can simply do the 1 plus I root 3 with your calculator. There is no need to bother yourself about that. So 1, if you have 1 plus I root 3, right, and you square that, you are just going to get minus 2 root 3, right? So let's say 1 plus I, forgive my handwriting, root 3 all squared is equal to what? Minus 2 root 3i, right? And we are told that z squared is equal to what? Minus 2 root 3i. We are supposed to solve this. Now, if you want to solve complex roots, right, there are a number of ways to do it. I would suggest you first change what we have here, this value here, into its exponential form, right? Now, if you draw this on the Cartesian, sorry, the Argand diagram, you are going to have minus 2 root 3i in this particular quadrant. It's going to be here, right? So if we start by finding the, so minus 2 root 3i is equal to, what's the magnitude of this particular vector? So if you want to find the magnitude, you know how vector magnitudes are calculated already, so that is not going to be a problem. Okay, so let's continue. All right, so the magnitude of this is just 4, right? Because you have 2 squared, square root of 2 squared, which is what? 4, then plus 2 root 3. When you square that, you are getting what? 12, right? And then this is going to give you 16, and you are getting, so 4 e to the power I. Now, what is the argument of this? You know that's tan inverse of what? So minus 2 root 3 over what? Minus 2. Then the minus 2 cancel. You are having tan inverse of what? Root 3. And you are very much aware that tan inverse of root 3 is 60 degrees, right? So this is 60 degrees. because we don't use the degree measure in our calculations most of the time, 60 degrees is just pi over 3 radians, right? So then we have pi over 3 here. You get it? I am using the angle here, just this angle here, right? It would give you the, okay, because this is just for, okay, let me just touch on this briefly. When you are finding the argument, right? The argument is the angle that the complex number makes with the positive x-axis. So over here, this is our positive x-axis, right? This is our positive x-axis. So if the complex number is in this quadrant, then this is the argument, right? If it is in this quadrant, you would first find the angle, which is this angle, right? And then subtract that from what? 180 degrees, right? So if it is in the second quadrant, you just subtract 180 from that. So let's say from the magnitude of that, let me show that briefly. Where is my eraser? Right. Okay. So you have the plane like, oh, right. And then you want to find the argument. I'm saying that if it is in the first quadrant here, the argument is just what you calculate, right? But if it is in the second quadrant, then you are simply going to have it being, if it's in the second quadrant, you find your tan inverse of, let's say, tan inverse of y over x, right? And then it's going to give you a negative number because of this part, right? So that will give you, let's say, negative theta, right? So the argument becomes 180 minus theta for the second quadrant. For the third quadrant, you get tan inverse of y over x, which is going to be a positive theta, right? But because it is in this quadrant, you just add 180 to it, so plus theta. Now, because we had 60 degrees for ours, you just add 180 degrees, you get 240. And then that's the same as what? Pi over 3. Sorry, 4 pi over 3. So we have 4 pi over 3 here, 4 pi over 3 here. Okay, so I 4 over 3 pi, right? Now remember, z squared is equal to 4 e to the power I 4 over 3 pi, right? We are supposed to find z, right? And clearly indicating both the real and imaginary part. So if we, that's what we are supposed to do. It means z is equal to what? Square root of this whole thing, 4 e to the power I 4 over 3 pi, right? Now, for the 4, it's just going to come out and you get 2 square root of what? E to the power I 4 over 3 pi, right? This is the same as 2 e to the power what? I 4 over 3 pi, or exponent half, because you know that the square root of any number means that number to the power half, so exponent half, and this yields 2 e to the power what? I pi 4 pi on what? 6, which becomes 2 e to the power what? I 2 over 3 pi, right? But you are not going to get just one number, so you add plus what? 2 pi k, right? Where k is equal to 0 or 1, because we are looking for square root, right? So if you are finding nth root, the nth root, right, k will be from 0 to n minus 1. So for nth root, k is equal to 0, 1, 2, up to n minus 1, right? Because this is just square root, it will be 0 and 1. So if we are to put, so z becomes equal to 2. If we are to put k as 0, we get e to the power what? I 2 pi on 3. 2 pi, so 2 over 3 pi. And if we are to put z as 1, we get so 2 e to the power, so 2 on 3 pi, right, plus 2 pi is going to be 8 on 3 pi, right? So 2, then I here 8 on 3 pi, right? You can just use your cos theta plus I sin theta to transform it into the x plus iy form, right? So having, let's just take the first one. So 2 e to the power I 2 on 3 pi becomes equal to 2, then cos 2 pi on 3 plus I sine 2 on 3 pi, right? And then you punch this into your calculator, you are going to get your real part and your imaginary part. So that now looking at the question says what? We should leave our answer in that form, right? So because it is a square root, know that you are not going to get only one answer. That's why we have two answers, right? The fundamental theorem of algebra. Okay, so let's move on to touch the next question. And I hope my handwriting is not is legible enough for you to see. Okay, so for the next question, we have, using De Moivre's theorem, we are supposed to simplify what we have over there. So we have 1 plus I all to the power 8 plus 1 minus I all to the power 8, right? Okay, so let's do that quickly. All right. So for this particular one, we've been given, so 1 plus I exponent 8 adding to 1 minus I exponent 8 giving us a 2 exponent x. Now how do we do this? Yes, you can simply do this by using your calculators, right? But let me just do because if you want to find 1 plus I to the power 8, this is not the time you are going to multiply that 8 times, right? But if you want to do it by hand, another thing you can do is convert it to the exponential form. So let me just do for this so that, so 1 plus I is the same as what? 2 e to the power what? I pi over 4. 2 e to the power I pi over 4, right? And then if you raise that to the power of 8, it becomes 2, it becomes what? 2 e to the power I pi over 4, all exponent what? 4. Sorry, exponent 8. 2, so 2 exponent 8, so 2 exponent 8 is, sorry, the magnitude is root 2. Oh, sorry. So root 2 here. So root 2 here. So root 2 exponent 8, right? Root 2 exponent 8. That's just going to give us 16, right? So we have 16 e to the power I, and then pi over 4 times 8 is what? 2 pi, right? That gives us what? 2 pi, right? So 2 pi. And everything here is going to give us 1. because remember the Euler's identity. So Euler's identity, it's what? E to the power I pi plus 1 is equal to 0. This particular identity aids in a lot of complex number calculations. So if you want to modify this, we can get e to the power I pi is equal to minus 1, and then what? Squaring both sides gives us, so e to the power I pi here, you square that, then minus 1 squared as well. This gives us e to the power 2 pi I is equal to what? 1. That is why I mentioned this here is going to be equal to just 1. So this is 16 here plus. When you do same for the minus, right, you are going to get 16 as well. But assuming you want to see that, if you want to see that, you can just punch it into your calculator and get your answer, right? But in case the questions are not um, objectives, that this is how you can go about it. So 1 minus I is equal to what? So we have root 2 again for the magnitude, e to the power I. Now this is going to be in, for the quadrant, you can see clearly that, this is going to be in this quadrant, the fourth quadrant here, right? So this, the argument of that is also going to be what? Pi over 4, right? And taking all of them to the power 8 is also going to give you 16 e to the power 2 pi I, right? And like I mentioned earlier, this is 1. So it gives you what? 16 is equal to 2 to the power x. That gives 32 is equal to what? 2 to the power x. And you are very much aware 32 is what? 2 to the power 5, right? So 2 to the power 5 is equal to 2 to the power x. And comparing the exponents, this gives us x is equal to 5, right? So it's as simple as that. I hope you understand it. Okay, so with this, we are supposed to, so let's solve this particular question here. We have e to the power 5 plus 3i all squared, right? E to the power 5 plus 3i all squared. And we are to determine which one presents the real part. Okay, so z is equal to e to the power then 3 plus 5i all squared, right? 3 plus 5i all squared. And sorry, 5 plus 3i instead. 5 plus 3i instead. So 5 plus 3i all squared. You can simply square the top. So if you have 5 plus 30i, all right, so let's continue. All right, so given this, we are supposed to find the magnitude of what? A cross B. Now, don't forget A cross B is equal to what? A dot, or magnitude of A times B sine theta. And for the cross product, for the dot product, A dot A dot B is equal to magnitude of A times the magnitude of B cos theta, right? Okay, so if now, in order to find the magnitude of um we know the magnitude of A, we know the magnitude of B, but we don't know the magnitude of what? Uh of sine theta. Okay, so let's continue. Now, with this, if you want to find sine theta, you can just use a calculator to find sine inverse of theta, and then the theta you get, you find cos inverse of theta. So we have cos theta here as what? 3 over root 10. You can just find, so theta is what? Cos inverse of what? 3 over root 10. Just find that using your calculator, and then you are good to go. Find sine of that. Okay, so with this sine theta, right, is going to be opposite over hypotenuse, which is 1 over root 10. So we know sine over root 10. So we know sine theta as what? 1 over root 10. A cross B is what? Magnitude of A times the magnitude of B sine theta. Now we have every parameter to solve the question. So the magnitude of A is given as what? Root 10. The magnitude of B is 1 over root 10. Minus 2J, right? You are supposed to find the Cartesian equation of the plane. All right. So, okay. So this times, let's say the last root is maybe A. Let's use A for the last root. The product of roots should be equal to what? The last term, which in this case is minus 5 over then the 2i squared, then everything here times A should give minus 5 over 2. Alright, so 1 4 times A is equal to minus 5 on 2. That means A is equal to what? Minus half. So the third root is minus half, right? You can go, if you, I was having a few technical this form, right? We've been given A, B, and then C. The area is going to be half the magnitude of the cross product of any two sides. So we can take maybe AB cross, let's say AC, right? So these are OB, and then OC is here. So for the AB, we are simply going to get minus 2, 3, 1. And then for the AC, so this for AB, and for AC, we are going to get 1 minus 2. This is 1. So 1 minus 2, 1, right? So the area is half, then cross product of any, so magnitude of the cross product, you have I, J, and then K, right? So minus 2, 3, 1, and then 1 minus 2, 1. You can interchange it. Do maybe AC cross AB. The cross product on its own will be negative, but then the magnitude will be the same thing, right? Because magnitude does not, uh, with the magnitude, there is no negative involved. There isn't a negative magnitude, right? Okay. So when you solve this with your calculator, it's going to be half, and then the vector you are going to get will be I plus J plus K when you solve the cross product, this cross product. Okay. And with I plus J plus K, that magnitude is what? Root 3. So it gives us the area as root 3 over 2. Okay, let's move to the next question. I'm hoping you guys get the concepts and what I'm going through. If you have any issues, use the chat box to prompt me so that we rectify it quickly, right? Okay, so let's move on to the next question. With the next question, we have been given, okay, so we have 3 more to go, and after that, we should be well equipped. At least we should have some general idea of what we are going to do. So with this short session, in addition to your preparation, going through your notes and slides from class and solving a few more questions, I'm sure you'd be able to go through a lot of them, right? Okay, so here we have been given what? Log I, sorry, we are told that if log z is equal to I pi minus 1 over 2 log 1 over 25, then what is the magnitude of z? We are supposed to find the magnitude of the complex number z, right? We would employ something here. So I pi minus half log 1 over 25. So log z is equal to I pi minus half log 1 over 25, right? One thing we should remember is we can first do a transformation here. So having half log 1 over 25, or we can even make it negative half log 1 over 25, right? You know that if you have a log b is the same as log of e to the power a, right? So this is the same as log of 1 over 25 all to the power negative half. Then that transforms to log to the negative half makes this 20. The negative makes this a reciprocal, so it becomes 25 to the power what? Half. Then that gives us log 5, because I mentioned earlier, if you want to find the a number raised to the power half is what? Square root of that number. So this whole thing now is I pi plus log 5, right? You are supposed to find what? The magnitude of z. So you have log z is equal to I pi plus log 5. How do we find the magnitude of z? We can simply take what? Inverse logarithms, right? Now remember, if you there is an identity in log which says that if you have a to the power log to the base a of b, it is equal to what? B. So keep in mind this identity here. Now, this log we are using is actually len, right? Natural logarithm. That is log to the base e, right? So that is the log we are using. We are using log to the base e, not log to the base 10 as used in the secondary schools. So let me mention again, this log here is to the base e. It has just not been written, but it is to the base e, right? So if this whole thing, let me even write it well. If this is log to the base e of z is equal to I pi plus of 5, right? We take both sides to the power of e. So e to the power log to the base e of c is equal to e to the power log to the base. Okay, so with the next one, you're supposed to find vector projection, right? And if you go through the Math 151 2016 PDF that you have, I'm sure most of you have it. You would see it clearly stated, right? So with vector projection, it's just we have the scalar projection and then the vector projection. With the scalar projection, you want to find, in simple terms, you want to find how a vector would look if it has been placed on another vector, right? How a vector would look if it has been placed on another vector. And the scalar projection is mostly represented by COMP base A, B, and then you see A dot B all about magnitude of A, right? So when you see this, it means what? Projection of A onto, sorry, B onto A. So in order to remember it, you can see here the B is on top of the A. So that is how you can see. And then for the vector projection, it's written as PROJ. So projection is, so down to B on A means the B is at the top and then you have the A down there. And that is A dot B. You have the proof already. So this is just a quick recap. All right, times A, right? So we are going to use this to go through the question. So sorry, I'm having a few connectivity issues at my end, but at least it's okay now, so we can continue. So for the magnitude of V, we are aware of how to find magnitude of V, right? So this is going to be square root of 3 squared plus 0 squared plus 4 squared, right? Which is simply 5, right? Because 9 plus 16, that is 25 under a square root, so you get 5. So we can go on. So projection of U on V, sorry, U on V becomes, so we found that as 15 over, and so you should, so that if you have any